Hi, welcome to AB Video 7.2b Part 2, even more on volumes by revolution using disks and washers. All right, number 16, you have a region bordered by y equals a half x cubed, which is this curve right here, y equals 4, which is that horizontal line, and x equals 0, which is the y-axis. So the region is this green shaded region, and the axis of rotation is y equals 4. Now y equals 4 is one of the borders, so you will end up with a disk. Now the axis of rotation is horizontal, so your rectangular strip has to be perpendicular to it, hence vertical. So when I go to draw it, then don't draw it too close to either end. You want to draw it really kind of somewhere in the middle so you can see what's going on. So here's my little tick mark for the bottom of my rectangular strip. Here's my little tick mark for the top of my rectangular strip. I am going to be rotating over this. So this length from here to here will be the same as this length from here to here. Join the outer, and there's your cylinder. So you can tell that your h is a dx, okay, and it is a disk. So it's going to be pi r squared h. My h is dx, therefore my limits of integration have to be in terms of x, which is left border, which is x equals 0, to right border, which is x equals 2. And then your radius, now again, be careful here. Your radius is this distance right here, from here to here, which is from here to here. Now, both of these points, if you could say, have an x-coordinate of x because they're above each other. But the y-coordinate on this one is 4 because that's the line y equals 4, whereas the y-coordinate on this one is a half x cubed because it's sitting on the curve y equals a half x cubed. So to get the length of this blue strip, you would have to take the length from the x-axis to the line y equals 4, which is 4, and subtract from it this little height right here, which is your 1/2 x cubed. So it's 4 minus 1/2 x cubed, all squared, etc., etc. And you're just going to use the TI at this point. I know it says TI-89, but you're just going to use the TI. Do be careful. People do forget the pi, or they'll write it down the first time and then it slowly disappears. Just make sure that your pi is still there. Okay, the region bounded by the graphs of xy equals 5, which is y equals 5 over x, which is this rectangular hyperbola. The horizontal line y equals 2, the horizontal line y equals 5, the vertical line x equals 5. You're going to take that region and revolve it about x equals 5, which is one of its own borders, so it will be a disk. So here is your y equals 5 over x in quadrant 1. Here's y equals 2, here's y equals 5, here's x equals 5. So if you drew them in all different colors, you want the region is the one that's the closed-in region bordered by all 4 colors. So it's this striped one. We're going to rotate about the line x equals 5, which is one of the, as we said, one of the borders, so it will be a disk. But since x equals 5 is vertical, our little rectangular strips have to be horizontal. So I'm going to go from here to here, reproduce that length there, and here's my disk. It is a disk, so it's pi r squared h. My h, as you can see, is vertical, so it's dy, so it goes bottom border to top border, which is y equals 2 to y equals 5. And then it's the square of the radius. Now the radius is from here to here, right? Because that's the radius. So how long is that? Well, that is from the y-axis to the line x equals 5 is 5, and then minus this little piece right here that's missing, which is x, because that's a horizontal piece. So it's the x-coordinate. So our radius is 5 minus x. We square that. That's dy, but I can't leave the x. I go back. If xy equals 5, then x equals 5 over y. So you have to replace your x by 5 over y. Okay, so here's another one. If you were doing this graph by hand, I would try and find the x-intercepts, which will happen when x equals 0, and then again when x equals plus or minus 3. So you would have this. You could easily tell that when x is positive, of course, the square root will always be positive. So when x is positive, your answer will be positive. When x is negative, your answer will be negative. And it has a domain, actually, of x's between -3 and 3. Okay, so you want to take the region bounded by that curve and y equals 0. So that's these two portions combined. And you're going to take that and revolve it around the x-axis. So that's going to be on one of its own borders, so that's going to give a disk. So you're going to have pi integral r squared h. And as you can tell from this, obviously I'll get, this has the same area as this. It's a symmetric figure. So the volume I get when I rotate just this piece of it is the same volume I'll get when I rotate that piece. So what I'm doing is just saying, you know what, I'm just going to go 2 times 0 to 3 as opposed to -3 to 3. Okay, so I have 2 times pi. My h is dx because it's horizontal, so that's from x equals 0 to x equals 3 of y squared. If you didn't want to put the 2, you'd have pi, and then you'd have x equals -3 to 3. Okay, but I can't leave this in terms of y because everything has to be in terms of x because of the tail that wags the dog. So I go back, and what was y equal to? Replace y by x, square root of 9 minus x squared. Okay? Etc., etc. And of course I could square each one and get x squared times 9 minus x squared. Actually pretty simple to integrate. Okay, region bounded by y equals 2 over x plus 1, y equals 0, better known as the x-axis, x equals 0, better known as the y-axis, and x equals 6. And we're going to take that region and revolve it about the x-axis. So you should know that y equals 2 over x plus 1, and we've done this before, has a horizontal asymptote of y equals 0 because the degree of the top is less than the degree of the bottom. You know it has a vertical asymptote, but x equals -1. Anyway, so you get this graph, and it's bounded by the x-axis, the y-axis, and the line x equals 6. So we're talking about this blue shaded region right here. We're going to take that shaded region and revolve it about the x-axis. The x-axis is one of the borders. We will get a disk, pi r squared h. My axis of rotation is horizontal. The rectangular strips have to be vertical. And when I rotate that, I will get a disk. My height is horizontal, so it's dx. My radius is the actual y coordinate in this graph, but I can't leave x's and y's together. So what I'm going to do is go back here and go, well, what is y? Y is 2 over x plus 1. And that's that. I actually wrote this one down but never did it, so let's just delete that.
And that's